So memory is one of the important thing actually. In computers there are different types of memories. Okay, primary memory, secondary memory, and processor memory. Okay, we'll learn more about all these things in the coming minutes. Okay, first let us see what is memory. Okay, memory is nothing but remembering things. Earlier days we used to write on books and papers and everything. Okay, it's a recorded thing. Like that, electronic computer will store the data in electronic format. Okay, so first you should understand that computer can understand only zeros and ones. Okay, zeros and ones. So we will represent any data. Okay, whatever the data will represent it as a combination of zeros and ones, like strings like this. Okay, so in order to computer to process or whatever, it needs to store this data. It's long data it has to store actually long bits of data. Okay, so computer memory is nothing but it's a storing of the bytes. Okay, storing of the bytes. So memory organization is nothing but how the memory is organized at different levels. Okay, we'll see one by one so that you will get the clear picture. So first we'll go to the what is memory cell. Memory cell. Memory cell is, I'll give a small example so that you can easily understand. Memory cell is nothing but anything that stores one bit of data. So take some physical example. For example, capacitor is there. Okay, there is a transistor at the input. There is a transistor at the output also. Okay, see, this is capacitor. So what will happen when there is some input voltage is there? This is if it is the right signal. Read. Okay, so what will happen? This is dynamic RAM actually. So just for example, I'm selling, this is one cell of the memory. One cell is nothing but it stores one bit. That means it stores either 0 or 1. In this particular case, if there is capacitor charged, that means some voltage is there. This is ground, for example. Okay, some voltage is there, some V volts, then it is treated as 1. If there is no voltage, then it is treated as 0. Okay, you can better understand. For example, this transistor is just like a switch. Okay, so when we apply some voltage, it acts as a short circuit and the input voltage will pass to the here. For example, if you want to write 1 to capacitor, what will happen? You apply the right signal. Okay, what will happen? This input voltage, whatever 1 voltage, will come here, because if you apply positive voltage here, it will close the switch, transistor switch, so it will charge the capacitor V volts. So that means you are writing 1 to the cell. Okay, now if you want to read the data, what will you do? You will apply voltage here, read signal. What will happen? This capacitor acts as a short, so this voltage will come out, V volts will come. So you are reading the whatever stored here. Okay, for example, if you want to write 1, what will happen? You apply V volts and you give the right signal. So this voltage comes here. So you already know plus V means 1, 0 volts means 0. If you want to write to 0, what will you do? You will just apply 0 volts here. You short it. So if it is already 1, what will happen? This voltage will discharge like this. Because if you are applying 0 volts, discharge and it will become 0. That means you have written 0 to inside. Okay. But here in dynamic RAM there is a small problem, because capacitor there is a lot of leakage. So continuously you have to refresh the data. Refresh means you have to continuously, if you want to keep 1, you have to keep continuously writing 1 here. But this is cheaper because it is less congested, less size, because density is more of the DRAM, because just one capacitor and 2 transistors. Okay, this is memory cell, one memory cell. That means it stores 1 bit of data. Okay, so memory cell, after studying, we'll see the different types of memories. Okay, first processor memory. What is processor memory? Processor internal memory, what is that? Registers, processor internal registers. Some cache is also there, cache memory is also near processor. Okay, then after processor memory you come to the main memory, or main memory is RAM. Okay, then secondary memory or auxiliary memory. I'll explain one by one all these terms. Secondary memory or auxiliary. Okay, this is just like our hard disk, flash memory, hard disk, and magnetic tapes, all these external memories. Okay, see, you can understand here. So what distinguish, all these are memories, but what distinguishes between them? Okay, registers, processor memory or main memory or secondary memory, all these can store the bits, but what differentiate between them? Okay, first is speed. This processor memories are fastest, this is slowest. Okay, I mean these registers will happen, so speed will increase as it will increases. Okay, then cost. Speed is nothing but access time actually, so processor works in nanosecond speeds. Okay, these registers also, internal processor registers also react at the same speed. Okay, these will react at lesser speed, this is more lesser speed. So whenever processor want to access internal register, it is quickest. Okay, ROM, it is little bit slow. Hard disk and it is very slow. Okay, speed will increase. Okay, so accessing speed will increase. Then cost will also increase. Okay, storage capacity will increase in this direction, because these are small memories. This ROM memory is little bit more, this is bigger. Actually it can store bigger memories. Why it is so? Because it's depending on the cost actually. So if you can, more cost you can put it, more memory you can put it. But here the density will increase. Not density, storage capacity. You can make hard disk in GBs. Here it is in, for example, hard disk. Nowadays hard disks are coming around 500 1 TBs. Okay, 500 GB or 1 TB. Okay, like that. ROM is coming 2 to 4 GBs, most of the personal computers nowadays. Like this, registers are with very less memory. Okay, just it is in MBs actually, cache and this one. Okay, few MBs. Okay, these are the different types of memories. Different types of memories, those will differ based on that requirement actually. This cost based analysis also, speed requirement. And here you have to remember, all those can store the data, but the only difference is that their capacity, their cost, their fastness, how fast those are acting. Okay, one more. This is also called memory hierarchy. Memory hierarchy. Okay, because even though all those can store the memory, these are different types of memory. This is very near to the processor, this is also near, but this is far away. Okay, so these are different, and also their physical construction will also different actually. Some are made with for example DRAM and SRAM, those are two different, those are used as ROM. Here it will use it magnetic tapes, their physical construction will also differ. Okay, you learn all these things in details actually. This is the memory hierarchy. So processor memory, main memory, secondary memory. Okay, so these are registers and flip-flops. Speed will increase, cost will increase, and storage capacity will like that decrease in this direction, reverse direction. Okay, see about memory actually. Okay, so why do we require memory? First of all, why do we require memory? To store the data and programs. Okay, not all data and programs, we require the memory. Okay, so how the memory is made up of? Memory is made up of cells actually. Okay, for example, take this, I'm roughly showing. For example, take this. Okay, these are cells. Okay, memory is made up, just like for example I'm showing. This for example. Zero, one, two, three. Okay. Memory is made up of cells, number of cells. See, take this individual cell. Okay. For example, this is one cell. Okay. Like this, memory is made up of large number of cells. Okay. So each cell, what does each cell do? Each cell can do storing one bit of data. Either it can store 0 or 1. Okay. Each cell can do. Okay. So cells are grouped to form addressable words. What does it mean? Cells are grouped to form addressable words means, for example, 8 words means word is nothing but length of the bits actually. Okay. For example, take this thing. This is 4 bit. Take this one. For example, cells are grouped to addressable words. Word is nothing but words. Word is nothing but set of cells. Set of cells. That means it can be 4 cell word. That means it can store 4 bit. Word means 4 cell, 8 cell, 16 cell, 32 cells, like that. Here cell means 1 bit. We can also call it 4 bit, same terminology, 8 bit, like that. 16 bit, 13 bit, 32 bit, 32 bit words. Okay. So for example, here I am taking 4 cells. Okay. 4 cells as a group. I grouped 4 cells as a group. That means this is a one word. That means 4 bit word. 4 bit word means I am clubbing 4 cells. Okay. That means it is a 4 bit word. Like this is another 4 bit word. Here another 4 bit word. Another 4 bit. Okay. Here how many words are there? 4 words. So for each one I am giving the address also. For example, this is word 0. Word 1, word 2, word 3, like that. So cells are grouped into the form of addressable words. See here, cell, this is cell, this is word. Okay. So each word, this entire length is a word. Each word is, I'm giving some specific address to identify it. Just like house, there are houses. If there are houses, we are giving each house one number, like that, to identify the houses. There are multiple rooms can be in the house actually. Okay. But in order to identify house, we'll give one number. Okay. Like that, that is address. Like that here also, for identify the memory location. Okay. This is a one word and this is the address of that memory location. Okay. Like that, 0, 1, 2, 3. Okay. So cells are grouped into to form addressable words. Okay. Here I am addressing. So here in cells, what is the important parameter? Time it is required to retrieve the data or write the data or to read the data. Okay. For example, this is the cell. Okay. Take this cell. If I want to read this data, that is time required to read the data. Okay. Like that, if I want to write some, for example, if I want to write some word 1101 to here, okay, the time required to write the data. Okay. That is the time required to retrieve the data from the memory and time required to write the data to the memory. Okay. To read or write, it is called access time. Okay. And if it is same, that means if I want to read from either from here, her, the time doesn't depend on the which location from it is, doesn't mean, I mean, for example, it takes same time. For example, if it takes 2 seconds, for example, if it takes 2 seconds to read from here, to read or write from here, if it is takes same time, 2 seconds, so that means whatever the location of the word, if the address is specified, if the time required to read or write is same, that means always 2 seconds, then it is called random access memory, RAM. RAM is nothing but time required to read whatever the location of the bits. Okay. Then it is called random access memory. You understood? Here the time required to read is always 2 seconds. For example, I am taking. Then if it is not like that, for example, if it is takes 1 second, here it is take 2 seconds, here it is take 4 seconds. Okay. For example, read this word takes 1 second, reading the second word takes 2 seconds. Like that, if it is takes, then it is not called random access memory. Okay. Random access memory is that time required to store or retrieve is same for all addressable locations. All locations it is same, then it is called RAM. Okay. So memory, how the memory is made up of, this is just introduction, I'm just learning. Memory is made up of either flip-flops or capacitors. Towards mode, capacitors are used in DRAM, okay, DRAM. Flip-flops are used in SRAM, okay. Okay, now the memory accessing, we just know. Actually memory is random access. This is random access because we can access any data in this sphere at the same time, okay. It doesn't depend upon the which location or which address the data is stored. Other than that, there is a serial access. Serial access means, for example, take a tape, large tape, okay. So there is a read head here, for example, reading. So if you start from here, it is reading serially, one by one after other. It goes this direction, okay. This is called serial access memory, okay. You understood? Because you start from here, you access this, this one by one. You directly can't go to here like that, okay. This is serial access memory. So serial access memory is used to store large amounts of data, gigabytes, okay. For that purpose, we'll use that magnetic tapes and magnetic memories and like that, okay. That is called serial access memory. CD-ROM and DVD-ROM. CD-ROM means compact disk read-only memory, okay. Compact disk read-only memory means this is one disk will be there. It is spiral type, okay. It is serial accessible. This rotates and data is stored in the spirals, okay. ROM means this is used by laser optical technique, okay. CD-ROM and DVD-ROM is used. Serial RAM and serial access. Serial access means we'll access one by one after. We'll start from here, we goes to here like this, one after another. That is called serial access memory, okay. In random access memory, whatever the location, it will take the same time, but in serial access memory it is not like that, okay. It takes larger time if the distance, okay. Now it comes to the CD-ROM and DVD-ROM. These are the using, here we will use that optical technique, optical laser. By using the laser we'll read and write, okay. DVD-ROM is more density because there are multiple layers, okay. So this is CD-ROM around 650 MB, you know that. DVD is more capacity. So this is just formal introduction. So whatever that, storage capacity, memory hierarchy. Memory hierarchy means I told earlier, processor memory, main memory and auxiliary memory. Memory, what are the memory hierarchy? How does we define? Storage capacity. Storage capacity means how much GB we are able to store it, okay. Access time. Access time means it is quicker or fast. How much time it takes to retrieve the data, store the data. So the more the faster, I mean the more the quicker we can access and write the data, then the more the cost per bit. So the cost per bit will increase as the access speed is increasing, okay. You have to remember this. Cost per bit will increase as we increase the access speed. That is, the more the fastest the memory, the cost will be the more for the bit. So processor internal memory is the costliest, okay. Then RAM is the costliest, then main, when compared to the main memory, this hard disk memory, okay. After that, one more characteristics we have to remember, this power supply. Power supply means the memory is able to retain the data even when the power supply is gone. That means some memories will lose the data as soon as the power supply is gone, okay. Some memories will store the data even the power supply is gone, okay. So some are able to retain the data even if there is no power once it is written. Some are will, as soon as power goes, some data will go away, okay. You understand that. These are the different characteristics. By using this, memory will be classified as processor memory, internal processor memory, main memory and auxiliary memory, okay.